NASA's Voyager 1 has shattered expectations, sending a message from deep space that defies all understanding.
NASA says its Voyager 1 probe, the most distant human-made object in the universe, is sending usable information to Earth again.
For 45 years, this spacecraft has traveled farther than any human-made object.
The spaceship left the solar system in 2012 and is currently more than 15 billion miles from Earth.
Now uncovering a signal so strange it could rewrite science. This isn't a glitch, but a structured anomaly that has scientists in turmoil. Voyager 1 has reached a realm where the universe's rules seem to break apart. Let us tune in as the cosmos unveils secrets that may change humanity forever. The key signal that challenges the universe. Space has always been a vast, enigmatic place, packed with secrets that stretch from our solar system's front yard to the most distant reaches of the universe. It's as if the cosmos thrives on throwing mysteries our way, daring us to figure them out. Among these enigmas lies a discovery so profound it may rewrite our place in the universe. This trailblazing spacecraft is one of humanity's proudest achievements. Launched in 1977, its main job was to study Jupiter, Saturn, and Titan, Saturn's mysterious moon. Along with its twin counterpart, it set off on an ambitious mission to explore the outer planets. Back then, NASA was riding high on the success of the moon landings, and the program that birthed these explorers felt like the next big step. The engineers who built these probes created machines that could withstand the dangers of space, radiation, cosmic rays, and the endless pelting of micrometeoroids. And these interstellar pioneers didn't disappoint. By the time they reached their destinations, they'd revolutionized our understanding of the outer solar system. They captured breathtaking images of Jupiter's swirling storms, Saturn's glittering rings, and the icy landscapes of moons we'd barely known existed. Before these celestial explorers, humanity's view of these distant worlds was fuzzy at best. Their missions turned myths into reality, showing us volcanic activity on Jupiter's moon Io and vast ice fields on Europa, hinting at oceans hidden beneath its surface. Fast forward to today, this distant wanderer is more than 15 billion miles from Earth, cruising through interstellar space at an unimaginable 38,000 miles per hour. It's the farthest human-made object from our planet, a lonely pioneer in the great beyond. But here's the twist. Despite being decades old and billions of miles away, the probe is still talking to us. Its signals, though faint, continue to relay data from the edge of the solar system. And recently it sent something strange, a signal so odd that it's thrown NASA scientists into a frenzy. The signal doesn't match anything expected. It's not a glitch or an error caused by the probe's ancient hardware. Instead, it's a coherent, structured anomaly that defies explanation. What could it mean? Theories abound. Some suggest it's a result of the strange environment this spacefarer now finds itself in. Others whisper about the tantalizing possibility of something truly out of this world. But until more data comes in, it's anyone's guess. To understand the gravity of this discovery, it helps to know where this cosmic messenger is. In 2012, the spacecraft crossed the heliopause, the boundary where the sun's influence gives way to the interstellar medium. This zone, uncharted and mysterious, is shaped by forces we barely comprehend. It's a place where stellar winds from ancient, long-dead stars clash with the faint breath of our sun. Its instruments have already revealed surprising details about this region, such as unexpected densities and magnetic fields. But this new signal takes things to another level. Some experts speculate the signal might be tied to interstellar phenomena we've never encountered before. Maybe it's evidence of cosmic particles interacting in ways that challenge our understanding of physics. Or perhaps it's a glimpse into the turbulent history of our galaxy, recorded in the energy and particles that this robotic explorer now encounters. Whatever the case, the data coming back is forcing scientists to rethink what they thought they knew about the space beyond our solar system. This resilient traveler's journey has always been a story of surprises. Even its early years were filled with jaw-dropping moments. Take Jupiter, for example. Its cameras revealed volcanic eruptions on Io, a moon that seemed like it belonged in a science fiction movie. Then there was Europa. Its icy shell cracked like a shattered windshield, hinting at a liquid ocean beneath. And let's not forget Saturn, with its intricate ring system and the hazy orange glow of Titan, where thick clouds shroud an alien world. These discoveries reshaped planetary science and fueled decades of research. But now, as this celestial explorer ventures into true uncharted territory, it's redefining what exploration means. It's no longer about snapping pictures of planets or moons. Instead, it's about listening to the universe itself, decoding the whispers of a cosmos that's been around for billions of years. And this recent signal, strange and unexpected, might be the universe's way of telling us there's still so much more to learn. These durable probes were built to last, but no one expected them to still be operational this far into their journey. Their power sources, fueled by radioactive decay, are steadily running out. NASA engineers have been ingenious in squeezing every bit of functionality from the machines, turning off non-essential systems to conserve energy. If all goes well, the probes might keep transmitting until the early 2030s. After that, they'll fall silent, drifting through the galaxy as relics of a bygone era. Even after they stop sending signals, their legacy will endure. Each carries a golden record, a time capsule filled with sounds and images meant to represent life on Earth. From the laughter of a baby to the strains of classical music, these records are a message in a bottle, cast into the vast sea of the cosmos. They're a reminder of humanity's desire to connect, even with the unknown. But what happens if these records are ever found? The odds are slim, almost laughable, but not impossible. In tens of thousands of years, the farthest of these probes will pass near another star, Proxima Centauri, and continue its silent journey around the galaxy. It's a humbling thought. Long after humanity has vanished, these tiny probes will carry our story, whispering it to the stars. For now, though, the latest discovery reminds us that space exploration is as much about questions as it is about answers. The universe is vast, complex, and full of surprises. And as long as we keep reaching out, we'll keep uncovering its secrets, one mysterious signal at a time. As Voyager 1's signal intrigues scientists, its journey into deep space highlights the resilience and creativity behind its mission. From solar winds to galactic secrets, from its early days in the 1970s, this extraordinary mission story has been one of resilience and unexpected success. It launched with modest expectations, carrying instruments designed to study planets, not the farthest reaches of space. Yet its mission grew with every milestone. The spacecraft survived the asteroid belt, captured detailed photos of Jupiter's storms, and delivered the first close-ups of Saturn's rings. Each discovery felt like a revelation, showing a universe far more dynamic and diverse than imagined. When it reached the heliopause, this space Voyager became the first human-made object to enter interstellar space. This milestone was more than symbolic. It provided unprecedented data about the boundary between the sun's influence and the vast emptiness beyond. Scientists learned about the interactions between solar winds and galactic forces, insights that continue to shape our understanding of space. Today, the spacecraft faces challenges its creators never anticipated. Aging systems and dwindling power supplies make every piece of data precious. NASA's engineers have become masters of improvisation, finding ways to keep the probe operational. Yet they know the end is inevitable. In less than a decade, its instruments will fall silent, but its journey will continue, a silent traveler carrying humanity's message to the stars. The Golden Record is perhaps the most poetic aspect of this mission. It speaks to the optimism and ambition of the era that created it. The record's creators included greetings in dozens of languages, sounds of nature, and a diverse selection of music. These choices reflect a belief in universal communication, a hope that whoever finds the record will understand its message. For billions of years, the cosmos has had enough time for any advanced technological civilizations to wander through the galaxy, even if they were moving at snail's pace. But here's the catch. Why is everything so eerily silent? The big brainy Drake equation, a framework for figuring out how many intelligent civilizations might exist, has been a hot topic ever since it was first dreamed up. Thanks to discoveries of exoplanets over the last 2 decades, some of its blanks are starting to be filled. But still, most of the juicy details, like how many planets actually host life, or how many of those life forms turn out to be tech-savvy, are big question marks. The Drake equation was groundbreaking when it came along, giving scientists a checklist of cosmic variables to tackle one by one. Things like how often stars form, how many have planets, and how many of those planets might be cozy enough for life. Multiply all those numbers together, and theoretically, you get an estimate of civilizations we could detect. But there are some major snags. First, we're pretty good at figuring out how often stars pop up in the Milky Way. By adding up star formation over the universe's history since the Big Bang, you might guess the galaxy has around 10 billion stars. But here's where it gets wild. There are actually closer to 400 billion stars in the Milky Way. That mismatch comes down to how star formation has fluctuated over time. Early on, star-making went gangbusters, peaked about 3 billion years into the universe's timeline, and has been slowing ever since. On top of that, the galaxy sometimes gobbles up smaller galaxies, giving its star count a hefty boost. The deeper problem with the Drake equation isn't just math errors, it's that it was built on an outdated view of the cosmos. Back when the equation was cooked up, scientists thought the universe was timeless and unchanging. Fast forward a few years and they discovered the universe had a beginning, the hot, dense Big Bang. The cosmos has been evolving ever since, which throws the original assumptions of the equation out the window. Instead, we need to zero in on what we can measure right now and inch our way through the cosmic fog. Today, scientists have a much better handle on the universe, at least compared to 60 years ago. We know a lot about how stars and planets form, what elements make up rocky planets, and how complex molecules might spring into existence. And exoplanet research has gone from a trickle to a flood. Back in the 90s, we didn't know about planets outside our solar system. Now, as of mid-2024, there are over 5,700 confirmed exoplanets. Sure, there are biases in the data. We're more likely to spot planets that are easier to detect. But scientists have ways to correct for that. The Voyager missions pushed humanity beyond the solar system, leading to the next chapter, the search for life among the stars. Rare gems in an ocean of stars. The Milky Way has roughly 400 billion stars. Around 80% are small, faint red dwarfs. 18% are sun-like, and the rest are too massive and short-lived to matter for life. Each solar system likely has 5 to 10 planets. Of those, 1 or 2 might sit in the so-called habitable zone, not too hot, not too cold, where liquid water could exist. Using a conservative estimate, 20% of planets around sun-like stars are Earth-sized, and red dwarf systems aren't good candidates for life. That leaves us with about 20 billion potentially habitable planets. Of course, there are plenty of ifs, ands, and buts. Maybe only half of the stars in the galaxy have planets. Maybe the habitable zones are smaller or larger than we think. Even with those uncertainties, the number of habitable planets could range from 5 billion to 50 billion. But having the right conditions doesn't guarantee life. Just because Earth got lucky doesn't mean life pops up everywhere. Carl Sagan, the famous astronomer, once suggested the odds of life arising might be as low as 1 in 1,000. Others think it could be closer to 1 in a million. There's no clear answer, and that's a huge problem for figuring out how many other civilizations might be out there. Even if life gets started, it doesn't always stick around. Earth's history shows that it took over 500 million years for life to evolve into something complex. And even then, it might have been a fluke. How often does life leap from simple to complex, to intelligent, to technological? No one knows. It could be as rare as winning the lottery 5 times in a row. Let's not forget the ultimate buzzkill, extinction. A high-tech civilization might only last a few thousand years before wiping itself out or getting smacked by a cosmic disaster. If that's the case, the odds of overlapping with another intelligent species in time and space get even slimmer. One idea is to use large language models, those AI systems trained on mountains of data, to communicate with extraterrestrials. These models could be compressed into small packages and sent to nearby stars via lasers or radio waves. The technology is already here. NASA has experimented with laser communication systems that could transmit data across vast distances. Another approach is to send physical probes equipped with ruggedized computers housing AI systems. Think of it as an upgraded version of the Voyager Golden Record. But instead of just pictures and sounds, these probes would carry interactive AI that could chat with alien civilizations. Of course, there are risks. Sharing advanced technology or knowledge with potentially hostile aliens could backfire. But the potential rewards, proving we're not alone in the universe, might be worth it. Imagine this. a digital legacy of humanity floating among the stars, encapsulating our achievements, our failures, and our curiosity. The very essence of human existence compressed into data, sent across the void, waiting for someone or something to receive it. What would we say? How would we introduce ourselves? Perhaps through AI, we could craft a universal message that transcends language and culture, a testament to our existence. Current technologies offer multiple pathways for interstellar communication. Laser transmissions are faster and more directional than traditional radio signals. NASA's lunar laser experiments have already demonstrated data rates exceeding 100 megabits per second. If this technology were scaled up, interstellar communication could become a reality. For instance, sending a compressed AI model to a nearby star system could take just a few decades. Another intriguing idea is the concept of gravitational lensing. By positioning a spacecraft far enough from the sun, it could use the sun's gravity to focus and amplify signals, enabling communication over vast distances. This approach, though technically challenging, could revolutionize how we interact with the cosmos. On October 2024, Voyager 1 faced a serious challenge. A glitch in its fault protection system deactivated its primary X-band radio transmitter, the crucial tool for sending scientific data and updates back to Earth. This forced a switch to the weaker S-band transmitter, last used in 1981, significantly reducing its ability to transmit information. NASA's engineers at the Jet Propulsion Laboratory in California responded quickly. By early November, they had successfully reactivated the X-band transmitter, restoring full communication and resuming the steady flow of data from Voyager 1. This swift resolution highlighted the team's skill and determination in managing a spacecraft far beyond its expected lifespan. The spacecraft remains operational thanks to its radioisotope thermoelectric generators, or RTGs, which convert heat from decaying plutonium into electricity. These generators lose about 4 watts of power each year, requiring NASA to carefully shut down non-essential systems to prioritize critical instruments. Despite operating in temperatures far colder than initially tested, Voyager's instruments continue to function, providing unique insights into interstellar space. The mission's success is also a tribute to Ed Stone, the visionary scientist who guided the Voyager missions for decades. His leadership, until his passing in June 2024, was instrumental in achieving Voyager's historic milestones, including its entry into interstellar space. NASA expects Voyager 1 to keep returning data through at least 2025, with hopes it might continue into the early 2030s. The ultimate question remains, what happens if we succeed? If an intelligent civilization responds, it would forever change our understanding of the universe and our place within it. The search for extraterrestrial intelligence isn't just about finding aliens. It's about answering profound questions about existence, evolution, and destiny. What if humanity discovers it isn't alone in the universe? Would it unite us or divide us further? Share your thoughts below, and subscribe for more thought-provoking content.